and we will continue where we let off, working with our compound interest, working with our two formulas that we found last time. One of them we use when we are trying to determine a future value that we will have in an investment, and another when we're trying to determine a necessary present value that we need to have today, a necessary principal value, in order to have a target future value from an investment. So we'll look right here. Ricky invests $1,200 into an account that earns 5% interest per year. Let's highlight those two key pieces. $1,200, 5% interest. How much, let's zoom out a bit, how much money will Ricky have in 20 years? So number one, it's up to us to recognize, what's the question asking? Are we looking to try and find a future value or a present value? Right, so in this case, how much money will he have? They're asking for a future value. If they're asking for a future value, we'll use this same formula that you saw us find in the last video. Next, let's identify what are the pieces that we already know. Well, this is the amount that's getting invested. The amount that's getting invested we know is our p-value. The rate right here we're working with is 5%. We can write that as a decimal, and we recognize, oops, we're missing our plus sign. And we recognize right here, writing this as a decimal, this is our r value. So r equals 0.05. And lastly, we know we're investing for 20 years. That's our t value. Nice and easy, t equals 20. Okay, so let's copy down that equation and then we can zoom in a little bit better. A equals p times 1 plus r to the power of t. If that's the case, first I'm just going to substitute in all the values I know. P we know is 1,200. 1 plus, and then I have an r. I know my r is 0.05. All to the power of t, that's to the power of 20. Nice and easy. If that's the case, I need to make sure I'm following my BEDMAS as I work my way through here. Now, the B in BEDMAS, we know it stands for brackets. What it really means is simplify anything inside the brackets that you can. Okay, so sometimes you skip by this if there's nothing in the brackets that can be simplified. In this case, we can. We have two pieces, a 1 plus 0.05. We can add those together. I'm working down, that is 1,200 times 1.05. I can do that in my calculator if I wish. All to the power of 20. Fantastic. Now I do still have brackets, but there's nothing inside the brackets I can work with, so I am all completely finished with the brackets in my BEDMAS. Next, I'm looking for exponents. Do I have an exponent? Yes, my exponent is 20. I need to apply that exponent next. So if I'm applying that exponent, I'm bringing down the 1,200 for the ride, and I'm putting into my calculator 1.05 to the power of 20. 1.05 to the exponent 20. Now your exponent button might look a little bit different than mine. Mine looks like this. This is the most common one, x to the exponent y. That's the button you press, and then 20. So my calculator says, wow, looks like a really huge number. It's not really. We have a decimal right away. It's 2.653. That's as much as I will copy. Lastly, finally, okay, I'm done with my exponents. Now I can finally work with my multiplication that has been waiting for us this entire problem. I'm working with 1,200 times 2.653 ... I remember that number went on forever because I left it in my calculator. Now I can just multiply this by 1,200. I'm left with $3,183.96. And lastly, we ask ourselves, does this make sense? Okay, how much money did we start with? We started with $1,200. How long did we invest it for? We invested it for 20 years. We earned 5% interest. We expect our money has gone up. We expect it's gone up considerably. I'm left with $3,180, nearly $84 there. That makes sense to me. If you're feeling really comfortable right here, I encourage you, pause the video, highlight, identify any key pieces to this next problem, identify what your values are for your p-value, your r value, your t value, or your a value, and then choose an appropriate equation. If you feel comfortable with that, great. If not, we're going forward right here, right now. Wendy is hoping to have $7,500. I don't even need to keep reading right now. She's hoping to have. That's in the future. Future us cares about an a value, not a p value. So here our a value is $7,500. I'll keep reading. In 3 years, oh wow, they gave us even more information right away. Our t value is 3. To go to college, how much money does Wendy need to invest today? Okay, how much needs to be invested today? That's a p-value. The amount that's invested today at 6% per year. There is our interest rate. except we need to make sure we change that to a decimal. 0.06 is our R value to reach our goal. So, because I paused so many times while reading this, I will read it once more. Wendy is hoping to have $7,500 in 3 years to go to college. How much money does Wendy need to invest today at 6% per year to reach her goal? We've already identified our pieces. Now we can recognize, okay, what is it we're looking for and what do we have? Well, we have our A value, that's our future value. We know we need that much. And what we're trying to find is the P value. That is the present value. That's the principal value. That's the initial amount that gets invested. And if we're looking to find a P value, let's head up to look at our equations. If I'm looking to find a P value, this is the equation I need because my P value is isolated. This allows us to calculate P from working with A, R, and T. So I'll copy down this whole equation. Our P value is equal to our A value divided by 1 plus R to the power of T to the exponent T. Fantastic. Now that I know those values, all I'm doing, same thing as before, I encourage you, pause the video, plug in the values that you're working with, and try and work your way down, and then see how you did. Because we're pushing forward right here, we know our A value is $7,500. 1 plus our R value is 0.06, all to the power of T. In this case, that's 3. As I work through here, I need to make sure I follow my BEDMAS. Following my BEDMAS, the very first thing, I need to make sure I evaluate what's inside my brackets. I can do that. That's 1 plus 0.06. Fantastic. So I'm working with 7,500 divided by 1.06, all to the power of 3. Great. I've handled my B, my brackets. Now I'm working with my exponents. Do I have an exponent? Absolutely, it's that 3. I work with my exponent. That's 7,500 divided by 1.06 to the power of 3. I can throw that into my calculator. 1.06 to the power of, we practiced this button before, to the exponent 3. I'm working with 1.191. 1.191. Now, when you're working with division, you need to be really careful. The order in which you divide numbers matters. So in that case, I'm going to need to rewrite my piece, but now I'm working with division. I'm finished my exponents. I'm working with division right now. Nice and easy. 7,500 divided by 1.191, and I end up with $6,297.23. Again, let's ask ourselves, does it make sense? We'll take a look at the problem that we started with. She's hoping to have $7,500 in 3 years. And we're looking to try and find how much money she needs to invest today. So we're expecting a number that's less than $7,500. It's only being invested for 3 years, so we don't think it's going to be super, super, super low. But it is going to be less than $7,500. Is that what we have? Yes, absolutely. Nice job, us. If you followed along, I'm hoping you feel more comfortable choosing an appropriate equation and using your equation. Nice work.